Oh, okay.
So methods have to do with the way the business, how the business works. There are certain guidelines how they do their things. So KFC is just chicken that has been fried. But you go and buy KFC, people go and buy KFC 25 Ghana cedi. How much is a pound of chicken? And you go and they give you 2-3 pieces. Why? Because someone has come up with a certain idea. This is the way I do it. Okay, so that is how it is. So there's always got to be a certain business rule, and that is the method, the way something is done. Uber. Okay, let's talk about those who pick the rubbish. Zoom Lion. Zoom Lion has a business rule. They have a certain method that they apply. What is it? We come to your place. Normally, we come in the morning and pick your rubbish. Are you okay? This is how we do it. We have a truck. It will be going to landfill every Wednesday. It will be going to the areas every Tuesday. Like this. And so that is what GIS needs, that to be a part of the system. If you don't have a method, you are not solving any problem with the GIS. You need to incorporate that method into the GIS, so that Ghana Water Company can sit down and see the spillage at this place from our GIS system. How did they get to know? Because their system, Ghana Water Company, through the pipes, able to distribute the water distribution. They take it to a higher elevation and then release it. Okay, I don't know these things because I am teaching GIS. I know them because every ordinary person out there knows it. Everybody out there knows it, and especially for a student to learn GIS means we assume you know some basics about how things work. Like everybody doing civil engineering has some background in physics and some science background. So this is it. The methods work together with the hardware. The software system, the hardware. The software itself implements the method. The people design the software. The people actually use the software, and then they make it available for other people to use the system as well. And then the system takes in geographic data with some attributes with it, and then they're able to now tell us that this is what is happening now. Are you okay? All right. So that is how GIS works. Very, very, very interesting. And so you shouldn't go into a GIS exam and flop so badly. Are you okay? You shouldn't do that. Okay.
Yes, sir.
All right. So we have metadata. Metadata is the next one, but I think we should take a break here and then we just continue again. I've talked for more than an hour. Okay, the time is 3 o'clock and I started around 1 to 2 o'clock. So I think I've done an hour, right? Okay. So maybe we can just take some 5 minutes break. Yes, so let's take 5 minutes.
But I have a question.
Okay, go for it. Yes.
Yes, I have a question. Yes, okay. We're talking about data attributes.
What?
Right?
It's talking about what?
Data attributes.
Yes, data attributes.
Data attributes.
Mm-hmm.
Yes. So we talk about nominal, which are classifications, interval ratio, which are intervals, and ordinal classes. Yes. But I was confused when we get into people and method. I was listening to it, but I don't know whether people and method are also data attributes.
No, this is my map for teaching you. And when we got to a certain part of the lecture, so if you can see my screen.
Yes.
At this point on this page, I told you that we are branching off. We branched and talked about hardware.
Yes.
Then we branched and talked about software. Quickly.
Okay.
We didn't talk a lot. We didn't say much about it. Then we came to data. Then talk about data attributes. Then we're coming back to
Okay.
people, and then you were not asking me. Okay, but I
All
understand.
right. I'm good.
I
I
understand.
wasn't following. The network was bad then. I couldn't see those
Well,
components.
as for network, please, I'm sorry. I don't think, you see, but the truth is that if you don't work on your network too, you are not going to do well, because maybe I'll say something you're supposed to hear and you don't hear it. That's it.
Yes.
You get confused. Online is not the best place to test yourself. Online is something we are trying. It may not be the best way to teach them.
Okay, I'm good now, sir.
Okay, let's pause for 5 minutes and then we continue.
Okay. All right.
Okay, so Florida, yeah, data. All right, so let's go on. Metadata. What is metadata? Metadata is data about data, okay, to provide sufficient information for the potential user of the data so that he can make an informed decision about the application and use of the data set. This one is like common sense question. If you all you need to remember is data about data, and that's it. But I've gotten some answers being given in the exam. You'll be surprised. Okay, data about data. That's metadata. Easy. What is the idea? The idea is that the user should be able to look at the data and tell, okay, this data was created by this company. This data is actually covering this extent, okay, geographical extent. This data is in this format, okay. So format, lineage, all right, all that attributes. What kind of thing would I get with this data? Okay, you get all the locations of incidences of this, all right, and you also get the age, and like with the metadata, you get to decide that okay, the data is good or it's not good for you, so that you can know, so that you don't waste your time. All right, so lineage, logical consistency, and completeness of the data, all that is what we call data quality information. The data quality information. So there are 3 sections of metadata that needs to be covered. Data quality information, then we have identification information, excuse me, then we have entity and attribute information. All right, this is how metadata actually looks like. Metadata, your hand is up, or forward. Is your hand up? Okay. We are now seeing
My hand is not up. Yeah, but I have a question. I need more information
Say again.
about data. You were setting
Your line is very, very bad. Your line is very, very bad. I can't hear anything you're saying.
I said you were explaining. You are explaining an example. Okay, I was saying. Can you hear me now, sir?
I can hear you. Yes.
Okay, I was saying you were explaining something. You were explaining data about data, like
right.
Metadata. You were saying an example. I didn't get the example clear.
Yes, so the example, I didn't really give an example per se. The example of metadata is what you are seeing on the board right now. I was only trying to get very practical with what metadata is about. And what I was saying was that if someone gave you a set of data, say in Excel, and then he attached something to it that described what is inside the Excel sheet, that is metadata. Okay.
Yeah.
What is an example of a metadata? Example of a metadata. You can't give an example of it. It's just any data anybody gives you and he tells you what is inside it. That's metadata. But then the data in GIS.
Okay, for instance, let's give a practical example.
Is there? I can't hear you.
Okay, let me
I can't hear you.
give an example. Hello? That's
Yes.
why I don't know whether it's your PC or something.
Go ahead. I'm listening.
I was saying, okay, let's say you are given a data of a class. Let's say a class of civil engineering 400 level is a data that contain so number of people, and then with the agenda, something like that. Can that be referred to as data about data, like metadata?
Okay, so it will be a summary of what the data is about. Yes, it will tell you that this data you are looking at was created by Abeliga. Are you kidding?
Yes.
And then
okay.
he created it on this date, and he's created it for AIT, the rector of AIT, and he just collected it only for a part of the class, not all of them. So you see, now what I'm saying now is metadata.
Yes. Okay.
I'm not giving you the actual data. I'm only describing it, and that is that is metadata.
Okay.
Yes. So on the now, when you look on the board, look at the board. Look on the board. Yeah. Look on the board. So here we have metadata. The actual data, this is not it. But you can see that we are trying to tell where the data came from, the origin of the data, Environmental Systems Research Institute. Publication date, 2001, January. Publication time, we don't know. Title, Buildings, SHB. Geoform, the form is digital, vector digital data. Okay, abstract. This data is simulated data set. It was created for instructional use with ESRI software, training modules, blah, blah, blah. It's not to be used for any purpose other than for which it was intended. So this even becomes some kind of disclosure, what we call disclosure. Someone publishes something, YouTube, a video of how to make money very quickly. He's gone.
Using Vodafone, so I also switch to MTN now.
So the abstracts, you can even see the purpose. Even before we even talk about purpose, everything that we are looking at is telling us about the data. So metadata is normally it's in real life. It's just a file which contains a lot of information about the bigger file. So it's a description of data. Okay.
Yes, please.
Okay. So the question that has been asked in previous times in exams, there's a question asked on metadata. The question was, why do you need to get metadata? Oh, I wish I could read the question to you. Let me see if I can get it so that's the way they answer this question. Let me see if I can get it for you. There's a question that was asked. So let me see if I can, look at that question. Okay, I'm sure this is question that was asked only recently. So let's see if you can understand it and probably answer it. Okay, let me see this guy. Salah images are. Okay, this guy didn't put a question there. Okay, but then I should have the question somewhere. So, PDF. Okay. Let me look in my download folder. Maybe I have it there. No. I would have been happy if I found this one. Oh, okay, let me open another one. I asked a question and so far I think nobody got it right on metadata. So you wonder whether they were sleeping or what, or maybe they've been drugged. Someone has given them some drug. I don't know. All the answers were wrong. Most of them were. Maybe someone got it right. Okay, so I'm going to share this, but I don't know how I'm going to do it. Let me just copy so that you don't see the person. I'll just copy his answer, the question and the answer.
Okay.
I'm putting it into a new Word document so that you will know what the kind of answers that people give. And then when you talk about it, people don't understand why they fail. Or you don't do extremely well. Sometimes you don't fail a course, but you don't do well, which is also not good. You have to do
yes.
Yes. Can you see my screen?
Yes, please. I can see it very well.
Very good. Okay, so here, give a reason why you need to ask for the relevant metadata for the project. So you have a project that you're supposed to do. But you've been given some data, okay?
Yes.
So give us a reason why you needed metadata. That's all. That's the question.
Yes, I can.
Have you seen his answer? All the information
Yes.
needed to interpret makes sense of. Look, even the English is bad. Is this one of the reasons students don't do well? All the information needed to interpret, make sense of, and analyze the data is called. Don't write English like that. It's called metadata. And you can see that that's wrong. That statement is so wrong. And you ask yourself, what happened? This is online. So is it that you don't even know where the lecture, the presentation is? I mean, for you to go and look at it and say, oh, is this the answer? This is why students are not doing. And this one I gave him 4. I was very generous. Very, very generous.
Okay.
Everything that appears in
Okay.
material, look at it. Everything that appears in materials and methods part of it. What is that? Totally irrelevant answer. Metadata can be stored a variety of ways. Keeping a paper notebook, all those occasions, is so wrong. So wrong. So wrong. So you, Abalega, who got the highest, your answer won't be concise. That's the reason you don't get the A++. Are you with me?
Yes, sir.
Anyway, we are saving this for YouTube, so let's cut it here. Is that okay? Let's just not talk more.
All right, sir.
But that is how bad it gets. When students online, you are sitting in the house in the comfort of your home, you just don't have a clue where the answer is. Oh my goodness. So a question like this demands that you simply talk about metadata, what it is. And if you want to get A+, you can go ahead and start talking about the different sections, identification information, okay, data quality information. Then it's like you get a full mark. Otherwise, probably you get some part of it. So that is
okay.
basically it, yes. Now let's look at topology. Or we should say that we should stop here and we are doing too much, eh?
Oh, no, sir. No, sir. We are not doing too much, sir.
Abel, are you sure?
Yes, sir.
Okay, great. So let's do some 30 minutes, then we close. All right.
Okay, sir.
Okay, so we're going to talk about topology. Now, what is topology? I put this picture there to help you to remember that topology is really about relationships. That is why I put this girl or this woman and this man, and it's like they are not agreeing. Are you okay? This is
Yes,
what
sir.
a lecture is supposed to be about. Topology is or deals with the relationship between geographic features, coverage features. That's all, relationship. So there is not, you see, in Ghana, we talk about relationship. I'm in a relationship. People go on Facebook. I'm in a relationship. I'm no longer in a relationship. That relationship is not, well, people have a whole lot of statements they can make about relationships. But the word relationship, I don't think we even understand it, what it is. Okay, so there exists a certain relationship between geographic features. Okay, now I've messed it up. Let me tell you now. Let me rotate the view. I think it's not looking okay. So shift plus. Shift minus. Okay, great. So topology is simply relationship.
Okay, welcome back, sir. Sir, I think your mic is off. Your mic is off, so I can't hear you.
Okay, I said that I always use the T-junction to explain topology.
Okay.
A special relationship between geographic coverage features or geographic features. So this is it. What's a relationship between?
So I can't see anything on your screen. Your screen is blank.
Sorry. I think that means I'm getting tired. I'm not doing certain things. Okay. So this is a center line of this road. That is the center line of this road. Normally, you want to look at objects from a model point of view. How do you model a road? How do you represent a road? You represent a road as a line, because roads are like snake. They snake around. Are you get what I'm saying? You traverse the terrain of a country by driving on the road. So you turn left, turn right, and it's just one. So it's a linear feature. So roads are linear features. So when you want to represent a road, you can literally do this. Now the relationship, this is what is happening. You see this first road, this road is going, and then we go and construct this road, and then we come, and then we meet it like this, as if they are having sex or something like that. Are you okay? No, because I have to say this now, because people don't understand the lecture, sometimes you wonder why people just don't understand. I have to say that this is like two things coming together, T-junction. At the crossroads, the same thing happens. So now I've turned this into a crossroads. All right, so this is it. If you want to look at the relationship between roads, this is a crossroads. Excuse me. This is how a crossroad, on the ground, a crossroad looks like this. Someone can turn right, turn left. I'm not even talking about transportation conflict at a junction. No. Someone can enter this way, okay? But there's something going on there. There's some kind of common thing going on. We are all sharing that junction, okay? So people in the relationship, they share the same thing. So how can you not understand something like topology, the concept? Except that we want to now break it down and say that, okay, topology has three different concepts. We have the connectivity, we have the containment, we have the contiguity. They are all about relationship between adjacent coverage features of features. Are you okay? Features are like,
yes, sir.
Okay. All right, so now we start with connectivity. So under topology, we have connectivity, we have containment, which is about polygons. Connectivity is about lines, points, arc, node topology. Containment is about polygon, okay, arc topology. Then we have contiguity. These are only words. The only thing that we are saying is that connectivity means connect at nodes. Arcs only connect at nodes. Containment says every polygon is made up of interconnected arcs. Contiguity says that we are able to tell which feature is next to the other by simply keeping the direction of every arc. Okay, that's it. So that we can infer a direction. All right. But sometimes when we over-explain something, then you lose the essence of it. So let me go back to my PDF, and you see that here we're talking about connectivity, area definition, contiguity. At the bottom left here, you can see we have connectivity, points along an arc. See that? Define. So we talk about the nodes, we talk about vertices, we talk about the fact that the arcs are, so an arc is made up of, vertices that define the shape of it, and then the beginning of the arc and the end of it, they are called nodes. So, and then the arcs connect at nodes. Like it's a story. You got to just put it in your head. Otherwise, you can't remember.